All right, boys and girls, welcome back to the drive-through for an extra cold edition of 7.4. We're hoping for maybe a day off school Wednesday because of the polar vortex. Good for you. Good for you, Carson. All right, I think I want to cuddle with my kids and my dog, but if I'm here with you, it'll still be a great day. That's for sure. All right, so speaking of polar vortex, how about vertex? Let's talk about some vertex. And with vertex comes quadratics and parabolas, and we're off. This first, hopefully you paused the video and watched and read this already, but this is a reminder that a square of length x has an area of length times width, which is x times x, which is x squared. Okay? It says sometimes a customer orders more, so model 4x squared with a diagram. Well, that's x squared, right? So there's 4x squared. Notice that x plus x that equals 4x squared. Why? Well, what's x plus x plus x plus x plus x? So hopefully that makes sense. Okay? All right. One of the customer service reps finds an envelope that contains the blocks printed. Write the order that shows two equivalent equations for the area of the blocks.
So we know we have x squared.
X squared goes here.
It's like 3x and 3x again. And then we have 9.
Okay, write the order that shows two equivalent equations. So this one could be considered x squared plus 6x plus 9, right? I think the other one they want is this. This is x, 1, 1, and 1. X, 1, 1, and 1. Not 3x, just 1, 1, and 1, right? So what is this? It's x plus what? 3. And what is this one? And what's the area of this entire square? Nope. How do you find the area? And these two things equal each other. Remember that? How would I get from there to there? I would have to FOIL it. Excellent. I get x squared plus 3x plus 3x plus 9, which is the same thing. All right. For what equations could the customer service write if they received an order for two blocks that are squares and both have dimensions increased by 1 inch compared to the basic block? Okay, so I think what they've got going on here is you've got like a little x and a little 1 and a little x and a little 1, okay? So it says what equations, but there's two of those. So I think here's what they want, Carson. Because this is x squared, and this is 1x, and this is 1x, and that is 1. Does that make sense? Okay? Verify them using a diagram. There's my diagram. Let's do the algebra. What do we do first? Multiplication? Or do we do exponents first? We do parentheses. Is there anything we can do to that? There's not. So then we would do exponents.
So we get 2x squared plus 1x. But it's 2x.
So you end up getting 2x squared plus 4x plus 2. Where this one is 2x squared. Got it. Okay? If a customer service receives an order for 3 blocks that are each squares with both dimensions increased by 2, so it's going to be 3 of these. Right? 3 of those. We got an x squared here. We got 2x, 2x, and 4. This is x plus 2, and this is x plus 2, right?
Yep. And then you're multiplying numbers.
So what are our 2 ways we can do this? Well, one of them would be 3 times x plus 2 squared, and the other one would be 3 times x squared plus 4x plus 4. Excellent, Carson. You're really getting this well. I'm proud of that. So this answer gets you to be 3x squared plus what?
12x.
Good job. Plus 12. Let's see what this one gets you. 3 times x plus 2 times x plus 2. 3 times x squared plus 2x plus 2x plus 4. 3 times x squared plus 4x plus 4. And you get 3x squared plus 12x plus 12. And that's a wha-bam. Right? Plus 12. They're the same thing. Moving on. Clementine is at it again. Oh, man. Here are some of the orders that have been chewed up, but they're missing the last term. Help her by completing each of the square. Ooh. Now we're completing the square with the front number not equal to 1. So check this out. Let's take it out. It's called factoring. So what do we have left in there? X squared plus what? 4x. See what I did there? Right?
Yeah.
Now, we want to complete the square. Now, this is what you caught on to on your homework yesterday. Okay? So what number do I need to write there to complete this square? Take the middle number, which is 4, divide it by 2. You get 2. Now square that. Right? So what number did we actually add to this? We actually added 8. Do you see how this is the same thing as this? Okay? So now watch what we would do. It's 2 times x plus 2 squared. Okay? ViewSonic. Squared. ViewSonic. Okay? This is weird. Just go with the video. Don't worry about it. It'll make sense at the end of the unit. So here, The answer to this is we would add an 8. What goes there? If I took a 3 out, what's going to go here? 3 times what is 24x? Not just an 8, but an 8x. Excellent, Carson. Now, what will we do to this 8 to complete the square? We need to divide it by 2 and then square it.
So that'd be 16.
Very good. Sorry, not 18x. It's not what I meant.
Yeah, this is really big.
Okay? So, now, I added a 16 inside the parentheses. But what number would I need to add to the original one to make this equivalent? 3 times 16. Which is what? 48, right? So I would need to add 48. That would complete my order as 3 tiles that were x plus what, Carson? Impress me here.
16.
X plus 4 squares.
Ah.
That's tough, okay? Alright, sometimes the quilt shop gets an order that turns out to be more or less than a perfect square. Customer service always tries to fill orders with perfect squares, or at least they start there and adjust. Always write their equations in a way that relates to the area of the closest perfect square. Alright, whatever. Now here's a real mess. Customer service received an order for an area of this. Help them figure out an equivalent expression for the area using the diagram. I mean, this would be x squared, right? X squared, because this is x by x. This is x. How much is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 12x. And then this is 12 by 1. Help them figure out an equivalent expression for the area. So are they saying to rearrange those? I don't even know what they want to do. Let me pause this for a second. Okay, first and foremost, Carson has counted closely and made me realize it's 13 by 1, which is much better because that's what that number is. So that's good. Here's, I think, what they want us to do, Carson. Make this into a perfect square. Now, we have 12 of these. So let's put 6x here. And there, right? So then how many are going to go down in here? 9, right? So this is x squared, 3x, 3x, and 9. Okay? Now, this is where the trick comes in. So how many x squareds do we have total? And now we have 2, right? How many x terms do we have total? 12, 12x. And how many do we have total? We have 13. Now, no, we have 12. We have 12, right? Look, 3x, 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 3x. Okay? So, how many individual numerals do we have? We had 13. We've used 9. So how many do we have left? We have 4. 1, 2, 3, 4. So how many short are we? We are 5 short. So here's what they want us to do. they want us to write this as 2 times x plus 3 quantity squared minus 5. That's how they want us to do these. Does that make sense, what we did there? Okay, stick with the video. This is going to be a long one. Okay, so now we have 3x squared. Whoops. We have 6x. And we have 10. Okay? So this cues me in, along with this, that it's going to be 2x for every square. So we got x squared plus 2x plus 1, right? And then we have another one. And we have another one. You are correct. We have too many. So this is 3 times x plus 1 squared. Now we have 1. How many do we have here? 10. Oh, that's what that says. It says 10. So how many too many do we have? That's right. Does that make sense? So we have 7 extra tiles here. Alright. So not everyone is in need of perfect squares. Determine whether or not each expression is a perfect square. Explain why the expression is or is not. If it is not, find the perfect square that seems closest. Okay, I got it. So this should be the 6x, cut it in half. What's that? So this is going to be x plus 3 squared. Now what is x plus 3 squared? Right? Were you confused by that? Okay, watch. Does that make sense? So, how far off is this? It's 4, so we're going to call it x plus 3 squared. We added 4 more. Does that make sense? So, do you see where I got the minus 5? What is x minus 5 squared, Carson? No. What's x minus 5 squared? Well, it's x minus 5. You need to write this out because you can't do it in your head, which is totally fine. Who cares? So what is it? X squared minus 5x minus 5x plus 25. Alright, well, we got to add a bunch. We wanted a plus 25. This one's a minus 3. So we have to add 28. Okay? We're good. Let's go over to B. I'm thinking this is x minus 4 squared. What's x minus 4 squared? That's a perfect square. right? Okay. Here we go again, ViewSonic. Alright. That's supposed to be a check mark. Told you this chapter's getting harder. Okay, this is 2 times x squared plus 4x plus 7. Alright, what's x plus 2 squared? You need to try to do this one in your head. X squared plus 4x plus 4. That's what x plus 2 squared is. Okay? So, we have a 7 there. So, let's see. I don't know. This is such a big jump for you guys. So, what we actually have is a 14. What we wanted to be there was an 8, I think. Hold on a second. Let's see. How do I want to explain this to you guys? This is already a very long video. Okay, so we wanted this to be this. You understand? So we need to subtract 3. But if we subtract 3 on the inside, since it's being multiplied by 2, how much would we have to subtract? 6. That is super hard. Don't worry, just follow along with the video. You're going to have questions. Okay, I got to keep going. We're almost done. So, okay, what would you guess this is? Yes, very good, Carson. So what is x minus 5 squared? What does that equal? X squared minus 5x minus 5x plus 25. So it is x squared. Is that what we have there? So this is 3 times x minus 5 squared. That's 3 perfect squares. Okay? What are we going to divide this one by? What do we have left? X squared minus 11x plus 11 halves. Okay? Half of 11 is 11 halves. Double that, and you get 11. This is what we want. That's what we want. And that would be 2 times x, x minus 11 halves squared. Oh man, no, you got to take half of 11 and square it. Just skip. Honestly, this is harder than it needs to be. That's algebra 2 stuff. Okay, let's see what else we got. For completing the square. Factor out a. Okay. Divide b in half. Square it. And then adjust your C. Already the longest video in history. Literally. Adjust, sure. C. Running out of time. Already out of time. Boom.